Well, guys, that song was late, right? So basically, uh, I love cheat codes, man. Okay, so anyway, right? So let's work out, right? So basically, today video is about the standard scale, right? So I'm just gonna run my library, and yeah, that's the one, right? That's the magic. So I'm gonna load my data set, right? So let me show you something cool over here, right? So basically I got this data set from the Kaggle, and you can see over here we have customer balance, income, limit, rating, card, age, education, gender, right, and student, marital status, right, and of course ethnicity, right. So I have loaded this data, right. So I'm not going to go through all the process because that's quite long. I already have done with this data set, so I'm just going to show you some of these tricks. So today we're going to talk about some statistics, right. Of course, the statistics, the machine learning and AI. Without statistics, machine learning and AI is nothing, right. So let's say the standard scale we are working today is this formula, right. So basically this also we got Z score normalization side. So if you're a statistician, you are quite familiar with this, right. So standard scaler is a pre-processing technique commonly used in machine learning and data analysis, right. Let me show you some cool stuff, right. So I'm gonna load my data set. So well, I'm not gonna use scalar right now, right. So I'm just gonna use this formula. You can see over here that's the x, right, and we have data frame, right. We are iterating through each the data points, that is our x, right. Let's say df, and we are basically just calling the balance, right, and we are calling each data points, then we are minusing those data point with the mean, right, and we're dividing those by the standard deviations that is identified by your data, right, and of course dot std, that's your pythonic function, right. So after that we are storing that into our x, right, and we can run this. Now you can see over here that is our standard scale, right. Same with the income, we are doing same, right. So each data point, that is our formula, that's the x, right. So minus mean, right, that's our mean, and divided by standard deviations, right, that's the standard deviations. So I'm just gonna run this. Now I'm gonna plot this. Now you can see over here that's how this look like. And well, the original scale does look like this, right. So I'm just gonna copy this and gonna plot this before I move on. Now you can see those are basically our original scatter plot, where we have our x as our balance and y is our income, but we have converted that into the z score, that is our formula, right. And now you can see over here we have a same plot, right, but our dimension has become changed now, right, because of the scoring method, right. Now I'm gonna use the same method from sklearn, that's the machine learning library, right. So sklearn, you heard about the sklearn, right. So basically it's a sklearn, but I have a habit of calling sklearn because just a habit, right. So from sklearn dot preprocessing import standard scaler, so that will help us to import those modules, right. And I'll say model scaler, where I'm creating a model and storing those standard scale model over here. So if I can run this and run this, now you can see over here that is our standard scaler. So I'm gonna fit those. So for that our code is we are creating two variables, x balance and y income. Then we are using those model, right. After model we are saying dot fit transform, right, and we have open and close parentheses, and we are using those same same columns here, balance and income, right. And we are just using dot reshape method just to convert them into the array, right. So basically I will show you, just give me 2 seconds, right. So now you can see over here x balance and y balance, right. So basically if I say like x balance, right, so dot and dime, so now you can see there's a two-dimensional, right. But if you say like df, right, and let's say balance, hopefully it's work, so dot and dime, so now you can say that's the 1D, right. So basically dot reshape -1 and of course a +1, that's give us a second dimensions, right. So after that I'm just gonna plot this, right, and you can see that that's the previous plot, right. So and if I can plot this, now you can see over here the blue one, oops, sorry. So I'm just gonna copy this, right, and I'm just gonna remove this one. Yeah, now you can see over here x balance and y income, right, and that is the plot I'm comparing. You can see if I can zoom this way bit more, you can see over here, oops, sorry, that's too much. Okay, So well, you can see over here, right, there's the blue and of course the red, but you can't see by the naked eye. So what I'm gonna do, I'm gonna reduce the alpha, right? Let's say alpha equal to 0.5. Yeah, now you can see over here that's become a bit shady, right? That's become like purple, right? And now you can see that basically both are almost same, right? So there is still a small deviations, right? And that will be fine, to be honest, right? So even we are doing imputations and everything, so that much deviation is not bad. So I'm gonna do a histoplot to check my x and x balance, right? So basically x come from our mathematical formula, right? The algorithm building, right? We have built this algorithm over here, right? And another is our just using sklearn. Where you go, where we go, there we go, right? So x balance, right? That's the one. So I'm just gonna do a histoplot and check how those basically how those column basically distributed, right? So now you can see over here, so the data is skewed, right? So there's a tail, there's a head, right? And there's a tail, there's a head, and you can see it's almost pretty much same, right? Yeah guys, so hopefully you enjoy this video. I will make another video on the other pre-processing techniques, right? So hopefully you enjoy this video and I will see you next time.